When I think about that quiet night in mid-December, well, I can't help but wonder, what would you feel if you looked up at the sky and knew that somewhere out there, a visitor from another star was drifting past our world? That feeling of seeing something not just distant but also ancient tends to linger, almost like a whisper in the dark. Not a myth, not a maybe, but a real traveler whose arrival has been calculated down to the very minute in the astronomical calendar. And the strange thing is that we often don't realize how extraordinary these moments are until they're already happening above our heads. You see, on the night of the 19th of December, while most of us will be heading home from work, settling into bed, or letting the soft rhythm of life carry us through another ordinary evening, a fragment of another solar system will be gliding across the darkness above. It moves quietly, almost politely, as if trying not to disturb the stillness of our night. And that's the thing, everything down here will look perfectly normal. Yet out there, a once-in-a-lifetime encounter will be unfolding. Not just passing by, but also reminding us that the galaxy is wider, older, and more surprising than we tend to imagine. And so I suppose the question becomes almost irresistible. What truly happens when 3I Atlas reaches its closest point to Earth? People often imagine danger, collision courses, dramatic headlines, and cinematic catastrophes. But the real story is much gentler, well, much more profound. On one layer, the familiar public message is simple. Earth is safe, no impact, no threat. But the deeper layer, the quiet scientific one, holds something far more intriguing. It's not just an object passing by, it's a chance to peer into interstellar space itself, to listen, or to try to listen, to how our solar system converses with the wider galaxy. And perhaps that's why this moment feels so strangely intimate. We are meeting a traveler who has crossed the cold between the stars, whether it came from a stable system or, well, whether it wandered freely for ages without a home. We may never know with certainty, but that mystery is part of the beauty. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple but meaningful, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? And let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. It's strange, how a journey that began far beyond the sun's warm glow can quietly end up weaving itself into the story of a small blue world like ours. And when we talk about 3I, Atlas drifting toward its closest approach, well, we are really talking about a path that does not belong to us at all. It's a path carved long before human beings learned to draw constellations on the sky. 3I Atlas is following a line that is older than memory, older than the Earth's first forests, older than the continents themselves, tracing a route that bends not in circles, but in wide open hyperbolic arcs. And that alone tells us something. It will come only once and then vanish into the dark again. Hyperbolic motion is, it's not the cozy loop we see in our familiar comets that swing back toward the sun every few centuries. No, it's not that at all. It's more like skipping a stone across the rim of a well. The stone doesn't fall in, it doesn't linger. It simply brushes past the gravitational boundary, letting the curve of space-time nudge it just slightly before continuing onward. So 3I Atlas isn't circling us, and it isn't bound to the Sunday. It is simply passing through the solar system as if it were gliding across a quiet cosmic courtyard, pausing only long enough for us to take a few breathless measurements before it slips back into interstellar night. You see, when the astronomers traced its orbit, the first thing they noticed was the tilt. Our planets travel on a nearly flat disk, a kind of calm and orderly racetrack. But 3i Atlas comes in from above that plane, angled sharply, almost defiantly, and, well, that angle is like a signature, a little whisper, telling us this object wasn't born here. The comets raised within our solar system share a family resemblance. Their inclinations, their speeds, their shapes are the echoes of a shared origin. But 3i Atlas moves differently. It feels different. Its momentum comes from another star's cradle. And that is important, because when we look at it, we're not just seeing a rock or a snowball. We're seeing a survivor of some distant furnace, a fragment from a planetary nursery we will never visit. Imagine, just for a moment, that 3i Atlas once circled another sun, perhaps warmer, perhaps cooler, perhaps surrounded by planets we can't even imagine. And then something happened, a gravitational scuffle, a near miss with a giant planet, maybe even a close encounter with a passing star, and it was thrown out. Not just moved slightly, but exiled entirely, flung into the deep and frigid corridors between stars, exiled for millions of years, and now it has wandered its way into our skies. Before its close approach, in late October, when it brushed past the sun at perihelion, the comet endured the fiercest radiation it will ever experience. Perihelion is a beautiful word, It means the point at which a traveler leans closest to the sun's fire. And for 3i Atlas, that moment was like stepping through a furnace door. The ices began to sublimate, transforming from frozen solids into gas, carrying dust with them, building a coma, that faint, ghostly halo, and then a long, trailing tail pulled outward by the solar wind. And it's not just gas escaping, it's history. It's chemistry older than the solar system itself. When 3i Atlas sheds material, it's not breaking down, it's revealing its past. But right after that fiery moment, something strange happens, not to the comet, but to us. The sun, blazing so brightly, becomes a kind of curtain, and the comet slips behind it from Earth's perspective, disappearing in the glare. Astronomers call this a solar conjunction, and although the term sounds mysterious, it's really just geometry. The sun stands between us and the comet, hiding it for weeks. It doesn't vanish, of course. It simply becomes unobservable, too close to the sun's glare for our telescopes to catch. And that misunderstanding, that little optical trick, has always fascinated me. It reminds us that sometimes the universe hides things not because they are gone, but because our vantage point is too limited. It's not the cosmos that is mysterious, it's our ability to see it that falters. After emerging from behind that brilliant curtain, 3i Atlas begins the part of its path that captures so much imagination, the approach toward Earth. Not a collision course, not even remotely, but an approach in the astronomical sense, close enough to study, close enough to watch, but far too distant to touch us. And yet, even knowing this, even knowing the math, there is something strangely intimate about the idea. A visitor from interstellar space drifting past our world. It's like someone walking by your window in the middle of the night, not entering your home, not knocking on your door, just passing through, carrying the scent of distant places. When we trace the comet's speed, we find something else remarkable. It's moving quickly, far faster than most of the icy wanderers tied to the Sunday. The escape velocity from the solar system is roughly 42 kilometers per second, but 3i Atlas moves faster still. And that excess speed is like a confession. Bound comets do not have such energy. This is the energy of the galaxy, the energy of a traveler who has drifted among the tidal currents of the Milky Way. Each kilometer per second is a story told in motion. And as it approaches, an odd emotional contrast forms. For astronomers, this moment is thrilling. For the rest of us, it would pass entirely unnoticed unless someone mentioned it. Because even at its closest, 3I Atlas will be far too faint for the naked eye. And it's not just distance, it's the delicate physics of dust and ice, the way light scatters off its coma. It's not a dramatic sky splitter, it's a whisper, a soft, pale smudge, visible only through sensitive telescopes. And that contrast is something I find deeply human. The universe can be roaring with significance, while we, on Earth, carry on with grocery lists and commutes and small, warm routines. But scientifically, this moment is extraordinary. We get to measure the way sunlight warms its surface, how the gas jets behave, how the dust tail curbs. We get to watch as the solar system's gravity redirects its path ever so slightly. And those tiny perturbations are precious. They help us understand the mass, the structure, the nucleus hidden beneath the bright haze. Observing a comet is like listening to someone speak from behind a curtain. You can't see their face, but the trembling of the curtain tells you who they are. Hyperbolic comets like this teach us something fundamental about gravity too. The sun never truly lets go. It pulls on 3I Atlas with all its strength, bending its path inward, then outward. But the comet has too much speed. It is like a dancer who enjoys the sun's embrace for only a heartbeat before spinning out of reach again. It's not bound, and it cannot be held. So the solar system becomes just one more hallway in a much longer journey. And when you consider the time scales, well, that's where the mind wanders. Because 3I Atlas has been traveling for millions of years. Millions. During that time, the Earth's poles wandered, continents drifted, species rose and fell. Our ancestors were, at different points, tiny nocturnal mammals, and later hairless apes, learning to chip tools from stone. And through all those transformations, the comet kept going, silent, unchanging, untouched. It's hard not to feel a kind of reverence for that endurance. It's not just a rock passing by. It's a witness to epochs. As it approaches the 19th of December, then passes that invisible marker on our calendar, a new phase begins. The comet is receding from the sun then, and simultaneously drifting past Earth's orbit from a respectful distance. It's not just moving outward, it's moving on. And that moment, the moment of closest approach, is our brief chance to observe it with clarity. But the comet won't feel anything special. There is no moment of recognition. It continues on the line the universe carved for it long before the first amoebas on Earth learned to divide. We, however, do feel something, a sense of curiosity, perhaps even longing. Because when something from another star system comes this close, well, it's hard not to wonder what stories it carries in its icy grains. This is matter that formed around another sun. This is chemistry shaped by alien seasons. When it sheds gas, that gas holds memories of a distant beginning. It's not just dust, it's the history of another world dissolving into the vacuum. And while we trace its motion, we also learn about ourselves, our limitations, our abilities, the way our instruments strain to capture photons from something so faint. The very act of observing becomes a reflection of human persistence. We build telescopes not just to see better, but to feel closer to the universe. And each comet offers a new reminder that we live inside a vast, dynamic galaxy, always intersecting with travelers from beyond. The beauty of this moment is that it is unrepeatable. 3i Atlas won't be back. Once it drifts away, gathering speed again as it escapes the sun's influence, it will continue into interstellar space, fading until even the best telescopes lose it forever. And that ephemerality, I suppose, is what makes it meaningful. Not just a scientific observation, but a fleeting meeting between worlds. And as we drift toward the next part of this story, toward the question of how we know all this, how we measure something so faint, so far, and so fast, the path leads naturally into another realm, the realm of our instruments, our spacecraft, our eyes scattered across the solar system. Because to follow 3i Atlas on its journey, we rely not just on Earth, but on a network of watchers orbiting other worlds and orbiting the sun itself. And that is where the next chapter begins, with the silent vigilance of those distant mechanical eyes waiting patiently in the dark. And so, while the comet dances past our Earth, while it carves that single curve through our skies and into memory, the question naturally arises, how do we even know all this? How do we, from our small blue island, track something so faint, so fast, so far? The answer begins not with a single telescope, but with a network, a kind of cosmic spiderweb stretched across the solar system, each strand an eye, each eye a watcher. You see, it's not just one observatory perched on a mountaintop anymore. It's not just one camera waiting in the dark. It's a chorus. It's a coordinated symphony of machines, orbiters, probes, satellites, all peering outward from their stations across space. And that's the beauty of this isn't solitary astronomy anymore. This is collective sight. From Mars orbit, for instance, we have a set of silent machines circling the red planet, built to photograph dunes and dust storms. And yet, well, they paused for a moment. They turned their cameras not downward, but outward. And in that pause, they glimpsed 3i Atlas. And it's important not just poetically, but geometrically. Because when we look from two angles, Earth and Mars, we get something precious. We get parallax. It's that same trick our eyes use to judge depth. One eye sees one angle, the other a slightly shifted view, and from that difference, distance is born. So when Earth and Mars look at the comet together, we don't just see it, we locate it precisely. That triangulation sharpens our knowledge, turning pixels into paths, blur into motion. But we go further still, much further. There are probes deeper in the solar system, floating far from the inner warmth. Take Psyche, for example, a craft built to visit a metallic asteroid, a mission rooted in planetary formation. And yet, even it becomes part of this great observatory. Even it looks up. And then there's Lucy, on her long journey to Jupiter's Trojan asteroids, instruments not made for comets, not intended for this task, and yet they too contribute. That's the thing about science in this era. It's adaptable. It listens even when it wasn't told to. Every camera, every sensor becomes a tiny ear pressed to the night. And with these multiple perspectives, we can do something remarkable. We can build a three-dimensional model, not just a flat image, not just a streak across the sky, but a real moving shape. We can see the coma, that glowing cloud of gas and dust forming around the nucleus. We can watch how the solar wind pulls the tail. We can trace how it changes, how it responds to heat, to time, to light. Even the shape of the tail tells us stories. A broad fan, a straight line, a double tail. Each one whispers secrets about what the comet's made of. Is it throwing off carbon or silicates or tiny grains of ancient ice? And Those details are not trivial. They're not just decoration. They are the record of another solar system. SOHO joins in too, the Solar and Heliospheric Observatory. Now, SOHO's job is to stare at the sun all day, every day. But to do that without being blinded, it wears a kind of artificial eclipse, a coronagraph, blocking the solar disk so we can see the delicate halo of plasma around it. And as luck or design would have it, this coronagraph also lets us glimpse comets. So when 3I Atlas swept past perihelion, when it brushed the edge of the sun's reach, SOHO was watching. It saw the comet survive the heat. It saw the tail flare, then thin. It saw in real time that the nucleus held together, that it had passed its trial by fire. That's a powerful moment, not just survival, but endurance, not just a visitor, but a witness. Meanwhile, down on Earth, telescopes tune their gaze upward. Professional arrays, yes, but also amateurs, backyard astronomers, night watchers. And from these many eyes, spread across the globe, came images of the comet's evolving structure. Ion tails stretching blue across the dark, anti-tails, strange backward streaks caused by perspective tricks, and shifts in brightness, small flickers that hint at jets, eruptions, changes in surface chemistry. Each one of those flickers, each faint increase or dimming of light, gives us information about rotation, about gas composition, about dust content. We learn whether the comb is thick or thin, whether the tail is rich in carbon monoxide or laced with sodium or ammonia. We start slowly to reconstruct what this comet is made of, and by extension, what its home system must have been like. And we do this not in isolation. We do it through conversation between data streams, between instruments. We correlate what Mars sees with what Lucy sees, with what SOHO sees, with what Earth-based scopes report. And, well, the story that emerges isn't fragmented, it's unified, it's alive. This really is the triumph of modern planetary science. Not just watching, but weaving. Not just measuring, but listening. Each observatory plays a part. No single eye could capture the whole truth, but together they come close. And it's not just technology, it's intent, it's curiosity reaching across millions of kilometers. And, well, by the time we reach mid-December, by the time 3I Atlas nears its closest approach to Earth, we're not guessing anymore. We're not in the dark. We have dozens of data points. We've mapped its path with such precision that we can predict its motion down to the minute. We know how close it will get. We know where it will appear in the sky. We know how bright or dim it will seem. And that changes everything. It turns fear into fascination. Because when the unknown becomes the known, when the blurry becomes the clear, then wonder can breathe. Then we can look up not with anxiety, but with awe. And maybe that's the deeper truth behind all this. The reason we built this network of eyes, the reason we listen for every whisper from the stars, it's not just defense, it's not just readiness. It's a kind of longing to understand, to connect, to see ourselves reflected in the orbits of strangers. You know, it's strange to think, but as this comet travels past us, we are looking at it from dozens of angles at once. It's like a sculpture being lit from every side. We are illuminating it not with flashlights, but with attention. And that act of collective seeing is perhaps the most human thing of all. Because when we build machines to watch the sky, we are also watching ourselves. We are asking, where are we in all this? What are we part of? And what else is out there, on paths not yet crossed, in systems not yet seen? And Um, as 3i Atlas closes in on that silent date with Earth's orbit, the 19th of December, all those instruments, all those watchers will be pointing, clicking, calculating. It will not be dramatic, it will not be loud, but it will be precise. And that precision is, in its own way, sacred. Not just because it lets us see the object, but because it lets us see beyond it, to what it means, to what it brings, and to what, if anything, might happen next, which leads us, gently, almost inevitably, to the next question. What does it actually do to Earth? What happens when a comet passes nearby, not in myth, not in media, but in truth, in physics, in numbers? Well, that's where we're heading next. Because now that we've seen it, we need to ask what it means to be near, and what kind of closeness is real in the language of the cosmos. So now we've seen it from every angle, from Mars' orbit, from Earth's surface, from solar probes and distant spacecraft drifting in the outer solar system. We've tracked 3i Atlas with a precision that, well, would have been unthinkable just a few decades ago. And now, with all that information, all those beautiful data points stitched into a kind of celestial map, the question becomes simple and not so simple. What will actually happen on the 19th of December? The thing is, and this is important, the answer is both reassuring and deeply profound. You see, nothing dramatic will happen. Nothing fiery, nothing crashing, nothing that will shake the ground or stir the oceans. But at the same time, everything will happen. Because this rare encounter is not about chaos, it's about clarity. Let's begin with what so many people instinctively ask. Is there a danger? Will it hit us? Will there be some gravitational effect that knocks things out of place? And the answer is no. Not just probably not. Not just it's unlikely, but no, with scientific certainty. Why? Because we've done the math. We've modeled its orbit using not just Newton's old clockwork, but also the subtle curves of Einstein's space-time. And what we find is that 3i Atlas will pass at a distance of over 70 million kilometers. That's nearly half the distance from Earth to the Sun. And in cosmic terms, well, that's not close. It feels close, yes. It sounds close, especially when the media says closest approach. But space doesn't work the way our streets do. In celestial mechanics, close is a vast chasm. It's the distance light travels in 4 minutes. It's far enough that even the moon, in its quiet orbit just over our heads, exerts more pull on Earth than this interstellar wanderer ever will. So what about gravity? What about its influence? Let's look at that. Every object in the universe pulls on every other object. That's the nature of gravity. It's not selective, it doesn't sleep, but it does weaken rapidly with distance. The force between two masses drops off as the square of the distance between them. And for 3i Atlas, the mass is tiny, the distance is vast. When you compare it to, say, the gravitational tug of the moon, or even Jupiter, or the sun, this comet's influence on Earth is less than negligible. It's so small it might as well not exist. It doesn't shift tides. It doesn't move tectonic plates. It doesn't stir our atmosphere or affect our orbit. And that's important because it helps us understand just how well behaved the universe can be when we know the rules. 3i Atlas is a guest, yes, but it's a polite one. It passes through, observed, studied, admired, and it leaves everything exactly as it was. But let's not stop there, because there are more subtle fears too. What about the sky, the atmosphere? Could debris from the comet cause problems, or fireballs, or radiation? Well, no, again, 3i Atlas isn't coming through the atmosphere. It isn't grazing Earth's upper layers. It's not shedding dangerous particles in our direction. The tail, that beautiful luminous thread of dust and ionized gas, is vast but diffuse. It's a whisper, not a wave. And it doesn't aim at Earth. It merely points away from the sun, as all comet tails do, pushed by solar wind. Now, some might ask, could there be a meteor shower? And here, well, there's a small poetic maybe, not now, not this month, not even this year. But in the distant future, it's possible if the comet's dust trail intersects Earth's orbit at some point. And only if it does that, we might see a gentle, faint meteor shower. Nothing catastrophic, nothing wild, just a shimmer, a brief rain of stardust from a starless origin. And even that would be a gift, because cometary dust is not just debris, it's chemical memory. Each grain holds clues about the composition of another planetary system. Imagine that being able to learn about the geology of a distant star's disk from a fleck of light burning up in our night sky. But most people won't see even that. Because the truth is, on the 19th of December, the vast majority of Earth's population won't notice anything unusual at all. The skies will be quiet. The day will unfold, as it always does, with coffee and work and music and sleep. No alarms, no flashes, no reason to look up unless you already know. And that's the strange, humbling contrast. Because while the day may seem ordinary on the surface, it is anything but ordinary to those watching. For the scientists, for the astronomers, for the dreamers with telescopes in their backyards, for them, this is the culmination of months, even years, of observation and modeling and waiting. This is the moment when a path through the stars brushes close enough to feel real. And it is real, just not in the way our bodies expect, not with sound or motion or heat, but with data, with numbers, with trajectories plotted against time. The impact, if we can call it that, is entirely intellectual, and yet perhaps even emotional, because to witness a traveler from another star drift past our own, that's not something that happens every day. That's a once-in-a-lifetime kind of quiet. It's not violence, it's perspective. It's the reminder that we live in a galaxy full of other systems, full of debris and dust and visitors. 3I Atlas is just one of them, the third interstellar object we've detected, but not the last. Not even close. And that's where the magic really is. It's not in the passing itself, but in the clarity it gives us. We understand its orbit because we understand gravity. We understand its chemistry because we understand light. We understand its speed because we've been watching. And every piece of that understanding makes the universe feel a little less silent, a little less cold. You know, it's strange. There's no collision, there's no explosion, there's not even a flicker of atmospheric entry. And yet, something powerful does happen. We meet something. We meet a piece of elsewhere. And that changes us, not on the surface, not with drama, but deep within, deep in the part of us that still wonders about the stars. So what will really happen on December 19th? Earth will spin, the clouds will move, life will go on. But at the same time, above the noise, above the weather, a speck of ancient ice and rock will slip quietly past, unnoticed by most, unforgettable to some. And the data it leaves behind, the measurements, the images, the slight curvature of its arc, will stay with us. It will enter our models. It will reshape our assumptions. And perhaps most importantly, it will remind us that we are part of a wider sky, that what we see tonight is shaped by what once burned in another sun's light, far from here. And that's the thread we'll pick up next. Because 3I Atlas is not just a wanderer, it's a messenger. It carries the dust and molecules of another place. And through those materials, through their composition, their structure, their silence, we can begin to read the story of where it came from. The next chapter is not about danger, it's about origins. Not about what might happen here, but what already happened out there. So if December 19th is a day of quiet passing, if no harm will come, no collision, no sky-shaking drama, then why does it still feel important? Why do we still look up, knowing there's nothing to fear? Well, maybe because what's out there is not just a comet. It's not just a rock. It's a message, a relic, a chemical time capsule from a world we will never see. And that is where things get interesting. Because when we speak about 3i Atlas, we're not just speaking about where it's going, but about where it came from. Somewhere out there beyond our sun's gentle sphere, in a cradle of another star, this comet formed. In dust, in ice, in cold, that even the outermost edges of our solar system cannot match. And it was shaped not by us, not by our history, but by someone else's story entirely. You see, when 3i Atlas passed through perihelion, when the sun's heat began to burn away its outer layers, what it revealed wasn't just gas and dust. It was chemistry. It was composition. The ices that evaporate into space carry fingerprints, the kind you can only read with a spectrometer. And those fingerprints tell us what it's made of. And more than that, they tell us what made it. Carbon monoxide, methanol, ammonia, silicates, organics. These are more than molecules. These are signposts. And when we compare them to the comets, we know the ones born in the Oort cloud or the Kuiper belt, well, we start to notice something. The ratios are different. The patterns shift. Some elements are too rich, others too poor. The comet's breath tells us it didn't grow up around our Sunday. It's not just about what's there. It's about what's missing. You know, scientists talk about the metallicity of stars, how rich or poor they are in heavier elements. And that metallicity shapes everything from the planets that form to the comets that coalesce. So when we study 3i Atlas, we're listening not just to ice boiling in the sun, but to the long ago whisper of a different solar nursery, with different conditions, different outcomes. And, well, this is how the story unfolds. 3i Atlas is what's known as an interstellar object, the third of its kind we've ever identified. The first was Oumuamua, long and mysterious, tumbling oddly through space. Then came Borisov, a comet more familiar, yet still foreign. And now this, 3 messengers, 3 interlopers, each one different, each one rewriting a page in our understanding of how stars and planets and their leftovers are made. Think about what that means. It means planetary systems are messy. They don't hold on to everything. They fling things out. And some of those things, icy fragments, rocky cores, drift through interstellar space for eons until chance carries them near another star. Until one of them ends up here. Not on purpose, not guided, just as a matter of momentum. And yet, we catch them. We read their signals. It's not just about chemistry either. It's motion, it's speed, its trajectory. The hyperbolic orbit, the steep dive in and out of our solar system, tells us this thing was never bound to the Sunday. And, well, the velocity tells us even more. It tells us where in the galaxy it might have come from, which direction it's moving. And that, in turn, might tell us which stars to look toward, which ones might once have held it. And the more we collect these objects, the more we identify, observe, compare, the clearer that map becomes. That galactic archaeology, that silent trade of debris between distant suns. You see, our solar system isn't a closed garden. It's more like an eddy in a great galactic river. We spin around the center of the Milky Way, and as we do, we pass through streams of material leftovers, from other star-forming regions, traces of other planetary dramas. So, so every interstellar comet is a reminder we are not isolated. The solar system is porous, it exchanges, it absorbs, it meets travelers on the road. And some of those travelers, like 3I Atlas, pass close enough to speak. But it's a fleeting conversation. The comet moves fast, too fast, and when it goes, it won't come back. Not in 10 years, not in 10,000, never. Its path will carry it back into interstellar space, this time outbound, never again, to curve near our Sunday. That's part of what makes this so important. We only get one look, one brief chance to learn. That's why astronomers rush. That's why telescopes worldwide and beyond are all turned toward this object. Because even if we miss one moment, it's a moment we don't get again. And the data we gather now might be the only clues we'll ever have about its home system. And there's something else, something even bigger. When we examine these visitors, we don't just learn about where they came from, we start to learn about how common they are. And this is where things get exciting. Because for every 3I Atlas we detect, there may be hundreds, thousands that slip past unseen, too small, too dark, too quiet. They come and go without notice. But as our surveys improve, as new instruments like the Vera Rubin, observatory begins scanning the sky in deep, fast patterns, we'll catch more, many more. Some might just pass through. Others might linger in the outer solar system for a while. And one day, one of them might be different still. One might show signs not just of chemistry, but of something more, something strange, something unexpected. That's the long game, really. The reason we pay attention, not because any one comet will answer every question, but because together they build a pattern. And patterns are where meaning lives. You know, we used to think the solar system was self-contained, that everything here was born here, that the rocks, the gas, the dust, all of it came from our own sun's accretion disk. But these interstellar visitors force us to think differently, to imagine not just planetary systems, but a galaxy in conversation, a galaxy where comets are messengers, drifting between stars like notes in a bottle. And when you start thinking that way, when you start seeing 3I Atlas not just as a guest, but as part of a network, part of a flow, you realize something even deeper. You realize that we, too, are part of that flow. The atoms in our bodies, the molecules in our bones, they're not from Earth, not really. They were made in stars, forged in fusion, scattered in supernovae, gathered again into planets. And those planets, well, they share. So 3I Atlas may be strange, it may be alien, but it's not foreign, not entirely, because the galaxy itself is a kind of home. And the more we listen to what these comets say through light, through mass, through motion, the more we learn about how connected we really are. And as we watch it fade, as its trajectory carries it back out into the dark, we're left with more than numbers. We're left with a sense of belonging, of being part of something vast, something ancient, something still unfolding. And, well, maybe that's what the next chapter is really about. Not science, exactly, not equations or spectra, but meaning. The human response to something so big, so silent, so far away, yet so moving. Because it's one thing to study a comet, it's another to stand beneath the sky and feel in your chest the weight of time and distance, and to know, truly know, that you are witnessing a moment that will never come again. And so, as we let that thought linger, the sense of belonging, of being woven into something wider than any map, maybe now is the time to pause, to step back a little and ask, what does it all mean for us? For people, for those of us who wake up go to work, laugh, worry, dream, and sleep, mostly unaware that just above our heads, a piece of another solar system is tracing its only visit past our world. It's easy, uh, it's easy to think of comets as cold things, distant, mathematical, silent, as stones. But well, when you realize that 3I Atlas has been traveling through the interstellar dark for perhaps millions of years, drifting across the emptiness, untouched, unseen, it starts to feel different. It starts to feel, I suppose, almost like a parable about time. You know, we live in days and hours, in coffee spoons and train schedules, but out there, the clock is set to a different rhythm. The comet has been alone for longer than our species has existed. It has drifted through dust clouds that predate our continents, watched the birth and death of stars that will never be named. And now, for just a handful of days, it comes close enough to be noticed, not just by astronomers, not just by machines, but by anyone, anywhere, willing to look up or even just willing to imagine. There's a kind of poetry in that. Because, well, that moment, that intersection is, in the grand scheme, nothing. It's a blink. It's less than a blink. If you measured time in the units of comets and galaxies, you'd barely notice it at all. And yet, for us, for you and me, it can feel like everything, because we are creatures of fleeting moments. Our lifetimes are thin slices, tiny chords in the vast symphony of the cosmos. We grow older, clocks tick, the seasons turn, but deep down, I think, we all hunger for connection to something more enduring. And that's what an interstellar comet offers. Not comfort, exactly, not certainty, but the chance for a little while to imagine your story against the backdrop of a much older one. It's not just a comet passing by, it's a messenger. It's an opportunity to step outside yourself and really see just how much you are a part of. And that sense of being part of something larger, well, that it can change a person. Not in the way a loud event changes you, but quietly, gently, like a new light in a familiar room. And maybe it also brings a kind of humility. Because if 3I Atlas teaches us anything, it's that the universe is not here for us. It does not revolve around our dramas, our victories, our losses. The comet does not slow for human concerns. It has its own path, its own timescale, its own destiny. And yet, the fact that we can notice it at all, that we can measure, study, understand, and even be moved by its passage, says something remarkable about us. It's not out there, it's in here. In our questions, our curiosity, our willingness to wonder, and, well, there's something else too, something that I think is often overlooked. When we gather, even if only virtually, to watch the sky, to share a live stream, to post a comment about where we are and what time it is, we are doing something ancient. We are building community around wonder. We are, for a moment, one species under one sky, connected by a question. What's out there? Who else is looking? How do you feel knowing what I know? And that is not a small thing. Not in 2025. Not ever. The world can feel scattered, divided, noisy. But for one night, for a few days, all over the planet, people can step outside, look up, and know they are not alone in their curiosity. That they are, for once, part of a shared story that transcends borders and languages and headlines. So maybe the real gift of 3I Atlas is not the science, though the science is wonderful, astonishing, profound. Maybe the gift is the way it calls us to attention, the way it invites us to slow down, to think, to remember that we are both small and significant. that we live in a universe where even the most fleeting meeting between two worlds can stir something lasting in the human spirit. I sometimes wonder what our distant ancestors would have made of a night like this. Before science, before telescopes, before even writing, people must have looked up at strange lights and wondered what they meant. They saw comets as omens, as messages, as stories written in the fair sky. Today, we have more knowledge, but the sense of mystery is still there. It hasn't gone away. It's just changed its shape. Now, the questions are more precise. What molecules make up that tail? How fast is it moving? Where did it begin? But the wonder is as wide as ever. And maybe that's why these events feel sacred, even if only in a quiet, secular way. They remind us that we are part of a story bigger than any single lifetime, bigger than any single civilization. 3i Atlas will not stop for us. It will not return. Its moment will pass, and it will vanish again into the dark. But the impact, the true impact, is here, in the questions we ask, the dreams we nurture, the sense of belonging that lingers after the night has ended. So, what will you do with this knowledge? Will you step outside on the 19th or the days around it and just breathe in the night? Will you share it with a child or a friend or someone you love and say, right, now, above us, a piece of another world is passing by? Will you remember years from now that you were here, alive, awake, part of this moment? And, well, that's the invitation. That's the hope. Not just to be passive watchers, but to be participants in the universe. To make meaning, to share meaning, to leave a record in memory, in photographs, in stories whispered before sleep. Because science, in the end, is not just about answers. It's about continuing the journey, about making the unknown a little less unknown, about stepping forward together into the next question. And as 3i Atlas moves away, as the days slip by, we begin to wonder what comes next. What other travelers are out there waiting to cross our path? What will we learn, not just about them, but about ourselves, the next time the universe gives us the chance to meet the unknown face to face? And as the last glimmer of 3i Atlas fades from our skies, as it returns to the deep quiet where it will travel alone once more, something lingers here with us. It's more than data, more than photographs or coordinates, or the chemical fingerprints we have gathered. It's the sense, and it's hard to put this into words, really, the sense that each such encounter is not an end, but a threshold. You see, we think of these events as singular, one-off, finished when the light fades. But, well, that's not quite true. Each visitor leaves behind a wake, a ripple that changes the way we see the world and the way we prepare for the next one. Because science is never still. That's the heart of it. The questions flow onward. The story never closes. What we've learned from 3i Atlas, the coordination of eyes across the solar system, the harmony of instruments on Earth and beyond, the poetry of public wonder, is not just a recipe for understanding one comet. It's a rehearsal for futures not yet imagined. So let's think for a dis-so moment about what lies ahead. Already, teams of engineers and dreamers are sketching plans for missions even more ambitious than those of the past. In control rooms and conference calls, in university halls and backyard workshops, people are talking about how we might one day send a spacecraft fast and nimble to intercept the next interstellar visitor, not just to look from afar, not just to catch a glimpse, but to chase, to meet, to sample, to touch and return, if not with our hands, then with our machines. And the technology we'll need, the propulsion, the navigation, the autonomous science, the ways of seeing and sensing what no one has seen or sensed before. All of it is being born right now in our era. It's not just technology, though. It's also a new kind of patience, a new kind of listening. The sky is vast, the odds are long, and these visitors give us very little warning. Some will slip past, hidden in the noise of stars. Some will be too dim, too small, too strange for us to catch at first. But every time we look up, every time we refine a survey or share a data set or train an algorithm to notice something odd, we make the next discovery more likely. We are teaching ourselves how to pay attention to a restless universe. And as we do, well, the questions we ask become larger. Not just what is it, but why are there so many? Not just where did it come from, but what can it tell us about the chances for life, for islands of chemistry and order elsewhere? Each object, whether it's a flash of dust in a telescope or a bright visitor that captures global headlines, is a piece of a mosaic. Each fragment brings us closer to seeing the big picture. So imagine, for a second, that future, whether it's in 10 years, in 20, or in the long centuries after 2025. Imagine a sky where instruments keep watch every night, software scanning for new motion, networks, alerting scientists and children alike the moment a new traveler is found. Imagine a time when the discovery of an interstellar visitor is not a rare shock, but a routine note, another stone in the river of the galaxy's story. And imagine what we might do then. Imagine a spacecraft ready, engines primed, the trajectory calculated in hours, not weeks. Imagine launching a probe that will intercept, orbit, and maybe, just maybe, return a sample of material untouched since before Earth was born. Imagine what it would mean to hold, in a lab, the ancient dust of a world no telescope could ever see, to taste with our instruments the water of another solar system, to find, perhaps, molecules that hint at biochemistry, far from the cradle we know. And it's not just dreams. Already in the halls of research agencies, the outlines are there. Blueprints, mission profiles, letters of intent. The scientific community has learned from the speed of Oumuamua, the brightness of Borisov, the approach of 3-eye atlas. Each time the window has been narrow. Each time the questions have come too late to build a full mission. But we're getting faster. We're learning what to watch for, how to collaborate, how to shift resources in real time. It's a race, but it's a race that gets easier the more we run it. And the meaning, well, it runs deeper than just hardware. Because every mission, every proposal, every test is a statement that we are not content just to watch, that we want to reach, to touch, to ask, and to answer, that the unknown is not just something to be feared, but something to be met. And that sense of reaching out, of refusing to accept the boundaries of our island, of our age, is in a way the most human thing we do. There's something beautiful, I think, about the idea that our greatest explorations will be built on the patience of thousands, perhaps millions of quiet acts, late nights in cold observatories, shared code written on long afternoons, an amateur astronomer's image uploaded from a city roof. Each act is tiny. Each one alone might seem meaningless. But together, well, together they change the world. And this is perhaps the real legacy of a visitor like 3-Eye Atlas. Not just the numbers, not just the data, but the web of curiosity it weaves, the way it pulls us gently but surely out of ourselves, out of our daily routines and into a conversation that began before us and will outlast us. that sense of a shared sky, a shared purpose, a shared future. You know, when people gather online or in parks or observatories to watch for a comet, to swap images or debate details or just to say, I saw it, what they're really doing is participating in something old and enduring. They're keeping a promise made by every generation that stood beneath the stars and asked, what is that? It's not just science, it's a kind of memory handed down, renewed every time someone points up and wonders aloud. And as we look to the future, the questions grow richer too. Not just, will we catch the next one, but what might we learn if we do? Could an interstellar object hold clues to life's origins? Could it be the carrier of new chemistry, new possibilities? Or would it, simply by its existence, remind us that the universe is stranger, more various, more unpredictable than we can imagine? The universe is a river, and we, for all our knowledge, all our plans, are leaves floating along, watching the banks change, listening for the next ripple. Every comet is a teacher, and every passage a lesson. The lesson of 3I Atlas is, I think, a lesson in readiness, in humility, in hope. That and, well, a lesson in patience too, because for all our cleverness, there will always be more waiting in the dark. More comets, more mysteries, more nights when the sky seems unchanged, until suddenly it isn't. And the best we can do is to watch, to share, to prepare, so that when the next traveler arrives, we are ready not only to measure, but to marvel. And that, maybe, is the most beautiful part of all, that the story never really ends. It just waits for the next chapter, for the next faint blur in the sky, the next data spike, the next shared moment of curiosity that reminds us again that we are alive, awake, and lucky in a universe still willing to surprise us. And as we turn the page toward whatever comes after 3I Atlas, we bring with us not just the knowledge we've gained, but the wonder we refuse to lose. And perhaps that's the truest measure of a civilization. Not the things it builds, but the questions it dares to keep asking. And so as we drift with the current of these thoughts, maybe it's time to sit quietly for a moment and let it all settle. The story of 3I Atlas, well, it's not a story of danger, not a story of destruction. It's a story about clarity, about perspective, about the beauty that appears when you realize that, for one brief passage, our planet and a fragment of another world share the same neighborhood. And, well, when you look at it that way, you start to see just how rare and valuable such moments are. The 19th of December is not, the day Earth faces peril. It's not a cosmic duel. It's more like a whispered greeting, a brush of wings in a vast cathedral of darkness. The comet glides by, indifferent to headlines and hashtags, and yet it leaves us changed, not outwardly, not in our oceans or tides or weather, but inwardly, where the real shifts in understanding always happen. We have watched with patience, gathering numbers and orbits and spectra, turning chaos into pattern, making sense of what once would have seemed impossibly remote. The instruments are sharper, the models more refined, but the wonder, the sense of awe, is as raw and true as it has ever been. That's the paradox, isn't it? The more we know, the deeper the mystery seems to become. Every question answered just cracks open another. And, that is the heartbeat of science. It's easy to say, I suppose, that this is just another scientific event. Easy to fold it away into the growing archive of things that have happened, things we have measured. But that's not the whole truth. Because what really matters is the way this comet, this simple traveler, exposes how much we do not know, how much is left, always on the other side of the horizon. The data remind us that yes, we are clever, yes, we are curious, but the universe is always cleverer still. And maybe it's the humility that matters most. The willingness to admit the limits of our knowledge, to stand under the open sky and let the questions hang in the air a little longer. Not everything has to be solved. Not everything has to be finished. Sometimes the most honest answer is to keep watching, keep listening, keep wondering. The universe, after all, does not hurry. Stars burn at their own pace. Comets take the long road. And time is not a clock. It's a landscape we travel through. So on the night when 3i Atlas is closest, what do we really see? Some of us see only darkness, the familiar comfort of an unchanged sky. Others, peering through telescopes, see a faint smear of light, a memory in motion. And for a few, it's a moment of connection, a chance to feel the scale of things, the scale of what is possible, the scale of what endures. We are here, we are alive, we are witnesses to a story bigger than ourselves. It's not just out there, though, it's in here. It's in the way we talk about it the next day, the way a child might draw a comet in crayon, the way someone might step outside in the cold, even if only for a minute, just to look up and imagine. These are small acts, quiet gestures, but they're how we say, I was here, I noticed, I cared. And maybe the most beautiful thing is that this is a shared story. We don't all need to see the comet to be part of its passage. Knowing it is there, knowing that we live in a universe that can still send us surprises, still slip a messenger through the cracks of the everyday, that is enough. It's enough to remind us that science is not only about knowledge, but about experience, about the privilege of being present, awake, and willing to listen. There's a lesson in that, I think, for all of us. The lesson is that wonder does not depend on spectacle. It doesn't depend on fireworks or thunder. Sometimes it's enough for something to be real, for it to happen, for us to know, for us to pause and say, this matters, even if only because it reminds us that we are not alone in our curiosity, that we are not finished growing, not finished dreaming, not finished learning. And we look ahead as we wonder what comes next. There is comfort in the knowledge that this is only one chapter in an endless book. There will be more visitors, more mysteries, more nights, when the world is changed in ways that most will never see, but some will always remember. The future is a constellation of unknowns. It waits for us, not impatiently, but with quiet expectation. And all we need to do, really, is to keep looking up. The science continues, of course. New missions are planned, new telescopes rise, new generations will take up the watch. But the feeling, the small, shimmering sense of wonder, that's what endures. That's what ties us to every human being who ever stood in the darkness, eyes wide, heart open, waiting for something to appear. Whether it's a comet or a question, a burst of light or the hush of possibility, it's all part of the same journey. So, well, if you find yourself awake some night, if you find yourself restless, unsure, or simply curious, remember that you are living in a time of extraordinary beauty. Remember that the universe is still writing its story, one slow line at a time, and you are in it. We all are. No matter where you are on the map, no matter what time it is, there is a place for you in this adventure. And all it takes, all it ever takes, is the courage to wonder. And that's where we'll leave this for now. Not with an ending, not with a tidy conclusion, but with an open door. Because as long as the universe turns, as long as comets cross the sky, as long as there are questions left to ask, the story goes on. And the next time you look up, the next time the sky seems too big or too dark or too empty, remember, something is always passing by, just beyond the edge of sight, waiting to be discovered. And perhaps in that vast, silent interval, you'll find not just a piece of the cosmos, but a new beginning for your own story too.